you're saying trees can read each other's minds. That's what you're saying.
Yes.
Okay.
Yes.
Perfect. All right, we got it solved then. Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 59. We are answering listener questions again today. Cheryl, whose question are we answering now?
Well, I'm so excited about this week's question, Ryan, because it comes from my stepson, Jack, who is 9. And I'm pretty sure that this is actually the first question that we ever got for our podcast. I just didn't record it in a formal way at the time.
Okay.
But when I first told Jack about this podcast, he was like, well, I have a question for your podcast. And he asked me this question. And so just recently I recorded him. So I think we should start by watching him ask his question.
All right.
I'm Jack, and I have a question for Cheryl. Do trees have personal space?
Oh my gosh, I love him.
Well, the question is for you, Cheryl. Specifically for you. Do trees have personal space? So I think that means you get to answer this question and do the whole lesson.
Goodness gracious. Well, we'll see how that goes. But this was so funny because he asked me, when did we start this podcast? Well, we've been releasing for over a year. So maybe a year ago, he asked me this question. And I laughed. And I was like, no, you need to ask a real science question. And then my husband was like, trees do have personal space, Cheryl. And I was like, what are you talking about? And he told me to Google image search crown shyness. So should we do that together?
Oh, Google image search.
On this journey.
Crown shyness. Should I share my screen while we do it?
Yes.
Okay. Okay, we're looking for crown shyness. Okay. An image search
image
though. Okay.
Results.
You want to describe what we're seeing?
Oh, I thought you were going to describe what we see.
I mean, I can do that too, but remember, this was a question for Cheryl.
Oh, sure. But this is the first time you're seeing this, Ryan. So what do you think?
Well, what it looks, and I wondered if it had to do with this. So it talked about the crown, which I'm assuming is kind of the top part of the tree, like the canopy, the top parts. And if you look, you're seeing multiple trees. And at least from these pictures, it shows that the leaves from trees come close to, but don't actually end up touching each other. It almost looks like, if you didn't know that these were trees, it would almost look kind of like rivers running around like in a marsh or something that are kind of, I don't know, wavy and kind of back and forth, kind of in weird, not really hard shapes, but kind of, and you can see the shapes a little bit. I don't know. How would you describe it?
I like the description of rivers, especially the ones where there's a blue sky in the background, since these photos are looking up, towards the tops of the trees from the base. But it reminds me of that type of paint that you can put on pottery that does a crackle effect.
Oh, sure. Yeah.
So that's what I'm seeing. But it's so beautiful. I had no idea this was a thing. So, I mean, to answer Jack's question, yes, trees have personal space. So I'm going to pack in my bags and get ready for your closing remarks.
Oh, that's it, huh? That's the whole lesson. We don't want any more detail than that. You don't care about why. You just say yes.
No, I'm so interested as to why. Because I just the idea of trees having personal space. I mean, Jack is a nature boy. He loves nature so much. He cares about trees. And so to him, it feels like trees having personal space feels like a personality trait or an emotional thing or things like that. And so I'm so interested to learn more about this.
Okay, well, let's dive into the pre-assessment. you kind of already have the answer of yes, trees have personal space, it sounds like.
Yeah.
But what do you think might be, well, there's kind of two levels. One would be, why do you think they have personal space? And then the second question would be, how do you think they maintain that personal space?
Ooh, interesting. Well, this definitely makes me think of our houseplants unit.
Mm-hmm.
And we talked in one episode about how plants do have some sort of a knowledge, and it's not knowledge like our brain's knowledge, but they do know things. Like they know which way is
Okay.
down and which way is up. You taught me terms for it,
Mm-hmm.
like geo something or other, and that has to
Okay.
do with the ground knowledge.
Mm-hmm.
Like when a seed is in the ground, it knows which way to
Mm-hmm.
start growing the roots, and it knows which way to grow its little shoot to start
Mm-hmm.
growing up out of the ground. And then there was another term you taught me that had to do with them knowing which way the sun was.
Mm-hmm.
So listeners, if they want to hear that term for themselves, I mean, they are welcome to go listen to that episode.
Or I could
Good
just
for them.
tell you too, if you want to know it right now.
I'm not remembering it off the top of my
It's okay.
head.
Well, you were right though that one of them starts with geo. It's geotropism.
Okay, and then so I think the other one would be tropism, because I thought they had the
Yes.
same
Yep.
piece of a
Mhm.
word.
It's heliotropism.
Solar. Oh, dang it.
Yeah, close
helo?
though, right? Heliotropism.
Heliotropism.
Having to do with the sun.
Yeah, and so that kind of established like, so plants do know some things. And so I wonder if
Mhm.
trees having personal space also applies to their roots. Like, will their roots not grow so that they're tangling up in each other too? Well, like, do their roots have
Okay.
that space? And I would assume the purpose behind that would be so that they're not like overgrowing and dying, because I would assume that like if they were like wall to wall trees, that there wouldn't be enough space for them to grow in a healthy way. And their roots extend further than like the width of the trunk. So they do need that space to be solid, I'm guessing. And then on the top half, we had also talked about in the houseplants episode where we talked about leaves growing larger when vines climb. You're talking about that like they're competing for sunshine, for sunlight. So I wonder if crown shyness has to do with competing for sunlight, but no, if that's like almost like the opposite, as far as like nobody's overlapping anybody. They all have their own space, but maybe that allows the whole forest to survive if everybody gets the sunlight. But I don't know how they would know that because they're not touching. So how do they know that the other branches are there if they're not even bumping into each other? And does this apply to all types of trees or only certain species?
What do you think?
I might guess certain ones because, or maybe like it depends on the way it applies, because not all trees have a canopy like that. Like I'm picturing pine trees that have branches that go all out. But I wonder, do they still have a form of personal space? But the canopy, like that look, you couldn't get that picture of every kind of tree. It would depend on the type for like how that, how they do that. But I wonder, like, no, they're from individual seeds. It's not like they're one tree, like a banyan tree. So how do they know if they're different seeds and different tree little systems? They're interconnected in some way that I don't know about. But what was your second question?
I think you've started to get at it, right? Because the first one was why, and the second one was how.
Oh, yeah.
And that's sort of what you're talking about now.
Yeah. But I don't know. I don't know how they know those things.
Yeah. But you think that you do think that it's something that they're intentionally doing.
Yes, I think it helps their survival.
Okay. So it helps their survival somehow, but you're not quite sure
Yeah.
how they can sense that
Yes. Yeah.
because they're separate organisms.
Yeah.
So for example, like I can't sense what your hair on your shoulders feels like because we're not the same organism. Same sort of a thing.
Yes. Or, well, more like if you blindfolded a bunch of people
Mm-hmm.
and they were trying to like find others in the room, but they hadn't even touched each other yet.
Mm-hmm.
But they knew that other person was like inches from them.
Mm-hmm.
You know, like, do you know what I
Yeah.
mean? Like, it
Yeah.
feels like, how can that be?
How would they know if they didn't have any way of at least touching them?
Yeah.
Okay. So you're saying trees can read each other's minds. That's what you're saying.
Yes.
Okay.
Yes.
Perfect. All right. We got it solved then. There's a couple of different ways that we can talk about this, Cheryl. The first thing to mention, though, is that scientists aren't 100% sure what leads to crown shyness. There's a couple of different
Whoa.
ideas, and we'll talk about what those are, but they don't seem to explain it in all circumstances. So it means there's probably some pieces, and it's more complex than we currently have understanding for.
That's exciting.
It is exciting. Anyone
Wow.
out there wants to find a new area of research for them to get into related to trees, there's one that you could do some research on.
That's awesome.
Yeah. First thing is most of the time, this happens between trees of the same species.
Okay.
But not always. There are documented cases where it happens between species. But most of the time when this happens, it's between trees of the same species, and it does not happen with all trees.
Okay. Got it.
Which I don't know how often you've been into a forest, but I've been in a few forests, and this is not, I would not describe this as the norm of what I've seen when I've looked up. So to
Yeah.
me, anecdotally, which is obviously not scientific data, but that matches what I would have guessed just because, you know, I don't know if I've ever seen it. I may have seen it before, but I don't know that I've ever necessarily seen it. So one of the things that they think might be going on is actually wind abrasion. When branches are close enough to each other that they overlap a little bit, if it's windy, they'll rub against each other. And that will lead to some breakage of parts of those. And if it happens enough, sometimes it can actually break off the areas where new growth occurs. So
that
then
it's permanently not going to grow.
Exactly. It's not going to be growing anymore because you kind of broke off or damaged the parts that would continue in that direction. And so that's one. And they've done different studies where they've looked at like different things where it's been windy and they've watched some of those things actual kind of develop. And so we know that that is one of the things that can contribute, but one of the things in one of the articles that I was reading was describing that, well, then you would expect you would see it more in forests that have higher winds or winds more often, and you don't. So that's one of those things where they're like, okay, so it definitely, they know it contributes. They've made observations and seen that it does contribute to it, but that can't be the whole thing.
Yeah.
So does that part make sense?
Yes.
Okay. The second thing, and this gets at one of the questions you were asking, how do they know? How do they know if there's others nearby? How can they know that? How can they sense that? And you mentioned a couple of things that trees, quote unquote, know, or plants know that we've already talked about, right? So we talked about geotropism, how it can sense gravity to know to grow like the main part of the tree up and the roots down. Do you remember what we talked about as far as how the tree actually knows that?
Well, with the seed, you were saying it might be or is, I forget which one, that the parts of the insides of the seed that like gravity affects them. And so then they would know which way because it might like settle to the bottom or things
Ye-
like that.
Yeah, so we talked about how the cells inside the seeds have like little tiny granules of things that yes can actually slowly fall towards the bottom, that gravity would pull them down. And so whichever side of the cell they're on, they know that that's the down side as one of the things. It's not the only thing, but that was one of the things that they could do. So it's a physical thing that they are actually detecting, that they could see. So that's another factor that they can actually use, not the gravity one, but that they can actually sense things from other leaves that are nearby. And so one of the things that leaves are really, really good at is sensing light. You probably knew that.
Yeah. Yeah, that makes sense. I mean, it's kind of a big deal to them. So
It is, because
Yeah.
they're trying to do,
photosynthesis,
there you go. And that photo
Mhm.
part means,
light.
yep, light, exactly. Right. So they're trying to actually do photosynthesis. That's the main purpose of most leaves, for trees especially. And so they have all of these different molecules in them that can detect different wavelengths or different colors of light. And there are certain colors that are more likely to be scattered off of other leaves. Does that make sense?
Yeah. Yeah, that makes sense.
Okay. So there's one called far red. So it's on the far red side of the color spectrum. If you remember, we talked about kind of the rainbow, and the light kind of has different wavelengths along the different colors in the rainbow. And so if
Yeah.
you're on the far side of the red end of the rainbow or the color spectrum, that's where a lot of light from the sun that's coming off of or bouncing off of other leaves often is in that area. And so we think that leaves from a tree can actually detect, well, we know that they can detect that far red light. And we think it might be using that to know when it gets close to other leaves, because they wouldn't expect to see that light. It would scatter away if you were really far away. But if you're really, really close, it's going to be a lot more intense of that particular wavelength of light. So they can actually, quote unquote, see when they get close to other leaves. Now, obviously, they don't have eyes, so they're
Wow.
not seeing in that sense, but seeing in the sense that they are detecting light and using that to be aware of other things around them.
That's so interesting. Wow. Yeah, I don't have that knowledge. So plants have knowledge that I do not. Well, we
This is
already knew
true.
that.
This is true. Although, to some extent, you have something very similar, because the infrared, which is even farther than the far red, because it's beyond the red, is infrared. You actually do something very similar. Did you know that?
No, and I can't think about what it would be. I mean, I can feel someone else's body heat. Is body heat infrared?
Heat is infrared. Yeah, exactly.
Oh.
So yeah, you could get close to a person without
Mm-hmm.
actually touching them, but still sense something that comes from them.
So what
Right?
I was saying about people being blindfolded was kind of incorrect, because really you could sense someone if they were close by.
Depending, if they're wearing,
Yeah.
a thick sweatshirt or something, you might not be able to feel that quite as easily, but yeah,
Yeah.
definitely. And even, I mean, it doesn't have to be people, but even if you get close to something that's hot, if you're like,
Yeah.
you get close to a fire and you're not physically touching it, but you can feel the heat increase. And that heat that you feel is actually infrared light. It's light that our eyes can't see, but our skin can detect. So again, it's not exactly the same thing, but it's a similar sort of thing that leaves are doing. Just instead of, they're not seeing it, but they are detecting it.
That's so interesting. Also, I'm going to start telling people that my favorite color is far red.
You should tell them that your favorite color is far red,
Yeah.
and see how they respond. One other thing that leaves can do is they also have something where they try to avoid shade, because if there's shade, obviously they're not going to get as much light and can't do as much photosynthesis, and that uses the other side of the spectrum, the blue side. And so when they detect a lot of blue light, that is an indication that they may be in the shade, and so they also try and avoid that. So just another example of how they can sort of detect things that are around them without actually physically touching them. So I think, and we talked about this a little bit, I think, in our houseplants unit, but plants are really cool and they're really amazing. But because they move on timescales that we don't typically see, we kind of think of them as stationary and not really doing a whole lot, when really there's tons going on. And plants can be very complex as well, even though they're not animals and they don't move in the same way, but they can do some pretty cool things.
That's so cool.
And with that, Cheryl, it is time for your quiz.
Oh, see, Ryan, I have quiz shyness, so I'm not going to be able to get near to the quiz.
Okay, well, that's fine because we're using Zoom right now and you're not near it
damn
at all. It's right here. Good try, though. First question. What is crown shyness?
Crown shyness is a condition where
Okay.
I don't know if it's a condition. Trees, the tippy tops of trees, their canopies, do not touch or overlap. They maintain a distance between them that looks fairly consistent.
Okay. Yeah, that works. You're like, I don't know. Is that good enough? Yeah, that's good. Do all trees exhibit crown shyness?
No.
No, they do not. What are two possible causes of crown shyness?
Wind that leads to friction and breakage of branches,
Mm-hmm.
and or what is it called? Far red?
Mm-hmm.
That they like the far red light, and then they're aware that somebody else nearby is also into the far red light. So then they're like aware that like somebody is nearby, even though they can't see or feel or like or touch that somebody. They like feel it. Maybe similar to how we could feel somebody's body heat, even if we're not touching that person.
Okay. Yes, I would. The one thing I would just tweak is it's not necessarily because the leaves like love far red. It's more that that's just what's kind of scattered or bounced off of other leaves and what's kind of left over after they absorb stuff.
So they don't love it?
Yeah, they don't
love
really care
everything
about it.
else?
Mm-hmm. Yeah, they're not interested in the far
And
red.
it's like the leftovers?
Mm-hmm.
Okay.
Yeah.
So the opposite of that. Got it.
Yeah, but your story is more fun.
Yay.
Okay. How do we know that our explanations for what causes crown shyness aren't necessarily the full story?
Well, have they done an experiment and proved it?
Have they
Isn't that
done
how
an
you
experiment and
know
proved
that
it?
that's like the thing in science is like you have your hypothesis
Mhm.
and you have your experiment and then you
Mhm.
come up with your theory and you have a control, but the control isn't working because when it's more windy, this isn't always happening.
There we go.
And so even with the light thing, if only certain trees are doing it, then yeah, it sounds like there's more knowledge that needs to be gained in
Yeah.
this area.
Yeah, but yeah, there are examples that don't fit our current explanations.
Mm.
Yeah. And you gave the example of kind of like where if it's more windy, you would expect to see more of it, and we don't necessarily see more when it's more windy, right? So that's an example. So, yeah. Final question, Cheryl.
Okay.
Do trees have personal space?
Sometimes.
Sometimes.
Yeah.
Yep. And we didn't even talk about roots. We only just talked about the top.
I know. What about roots?
Well, think of it as similar. It's not quite the
Okay.
same, but there's some similar stuff going on underground where there are ways that they can sense that there's other roots around, and they try and kind of like stay in their zone for the most part. So
yeah, they have personal space.
yeah.
That's so cool.
They understand. You need to back off sometimes. Leave me alone. Just let me do my thing. Well, that's all we have for this week's lesson. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.